In our last unit, we were taking a look at primary trig ratios and how we could use them to solve for sides and angles in a right angle triangle. In this unit, we're going to start investigating other types of triangles that do not involve right angles. First, let's take a look at this question here. In this question, they're asking you to determine the length of side BC, and I've constructed a perpendicular line from vertex A down to BC. I now have two right angle triangles. The one on the left is triangle ABD and the one on the right is triangle ADC. I'm given an angle in triangle ABD, 55 degrees, and I know the hypotenuse, 24 centimeters. Given the information in that right angle triangle, I can use cosine of theta equals adjacent over hypotenuse. Substituting in what I know, I get cosine 55 equals x over 24. Cross multiplying to isolate the x, I get x equals 13.8. In the right hand triangle, I'm not given angle theta, and I need to know at least one of these two angles in order to use my primary trig ratios to determine the length of y. So I'm going to use the triangle on the left hand side, triangle ABC, and determine the length of side Z. Substituting in, I can use sine of theta equals opposite over adjacent. Sine of 55 degrees is going to equal the opposite side, which I've represented with a Z, over the hypotenuse, which is 24. Plugging everything into my calculator, I now know that Z is 19.7 centimeters. I can use Z and H in the triangle on the right hand side, triangle ADC, to solve for angle theta. Z is the opposite, H is the hypotenuse. I'm going to use sine of theta equals Z over 50. I know that Z is 19.7, so sine theta is going to equal 19.7 over 50. Moving sine over to the other side, making it sine inverse, I can calculate that theta is going to equal sine inverse of 19.7 divided by 50. When I plug everything into my calculator, I end up getting theta equaling 23.2 degrees. Now I can use theta with the hypotenuse to calculate the adjacent. Plugging everything into my equation, I'm going to get cosine of 23.2 equals y over 50. Cross multiplying, I get 50 times cosine of 23.2 is going to equal y equals 46. Now I know x is 13.8 and I know that y is 46. X plus y is going to equal the length of side BC. Punching that into my calculator again, I've determined that side BC is 59.8 centimeters. So I've just shown you how I can draw an altitude going from vertex A down to BC. I can use what I know about primary trig ratios to solve for the length of BC in triangle ABC. In this unit, we're introducing the sine law. The sine law states that in triangle ABC, sine of angle B over side B equals sine of angle C over side C equals sine of angle A over side A. We'll use the sine law in this form when we're trying to calculate an angle. We can also represent the sine law by saying side A over sine of A equals side B over sine of angle B equals side C over sine of angle C. And we use this form of the sine law when we're calculating a side length. Let's take a look at how it's done. To start off with, I'm going to use sine of B over B because I know angle B and I'm given side B. That's going to help us. And I'm going to use sine of angle C, I don't know that one, over side C, which I do know. So basically I have a ratio here and I have one unknown, which is right here. And now I can solve for angle C by using the sine law. Plugging in what I know, I get sine of 55 over 50 equals sine of C over 24. I'm going to move the 24 up to the left-hand side, so I get 24 times sine of 55 over 50 equals sine C. I'm going to calculate what I have on the left-hand side to 4 decimal places. Then I'm going to effectively move sine over to the left-hand side, and it becomes sine inverse. So the sine inverse of 0.3932 is going to equal angle C. And that helps me calculate angle C being 23.2 degrees, which is the same answer I got in my other calculation. Now that I know that angle C is 23.2 and angle B is 55, I can calculate what angle A is. The three angles inside this triangle have to add up to 180, which means that angle A is 101.8 degrees. Now I can use the sine law in this format to calculate Now I can use the sine law written this way to calculate side A, and side A is the same as BC. Plugging in what I know, angle A is 101.8 over side B, which is 50, and sine of B is sine 55. Rearranging this equation and solving, I can calculate side A is 59.74 centimeters, which means side BC is 59.7 centimeters. And that's how you can use the sine law to calculate sides and angles in acute triangles.